Hi everyone, and welcome to this video going over lesson 27.1 and 27.2, factoring trinomials. Up until this point, we've been factoring out a greatest common factor, a GCF. But if you look at the trinomial here, x squared minus 2x minus 15, there's no number that divides both x squared, 2x, and 15. The only value that divides all three of these terms is 1. Which means the GCF is 1. But when I divide by 1, that doesn't change the polynomial. So we need a new factoring technique for how to factor trinomials with a GCF of 1. So we're going to do some investigating. Consider the binomials x minus 5 and x plus 3. Determine their product. That means that we want to multiply them together. So I'm going to draw my magic box. I have x minus 5. And x plus 3. X times x is x squared. X times negative 5 is negative 5x. 3 times x is 3x. And 3 times negative 5 is negative 15. When I combine my like terms, I am left with x squared minus 2x minus 15. With factoring, we are trying to work backwards. I want to know, is there a way to start with our answer, x squared minus 2x minus 15, and figure out that its factors were x minus 5 and x plus 3. So in part B, it says, how is the coefficient of the trinomial's middle term? So it's talking about the number in front of the middle term, so negative 2. How is this term related to the constant terms of the binomials, negative 5 and 3? So how do I get negative 2 from negative 5 and 3? Think about it for a second. In order to get negative 2 from negative 5 and 3, I added them together. So I have to think about two numbers that will add to negative 2, that middle term. And in part C, it says, how is the constant term of the trinomial? That will be the negative 15. Related to the constant terms of the binomials. Once again, the negative 5 and the 3. To get negative 15 from negative 5 and 3, I have to multiply those values together. So this is going to be like a little puzzle. I have to think of two values, such as negative 5 and 3, that will add to get that middle term of my trinomial, but multiply together to get the constant term of my trinomial. So the way we figure this out is we draw a magic X. When you have a trinomial, you want to label your coefficients A, B, and C. The imaginary number in front of your x squared is 1, so A is equal to 1. Your B is 7, that's the coefficient of the middle term, and your C value is 6, that's the constant term. On top of our x, we are going to multiply our a and c values. So 1 times 6 is 6. And on the bottom, we're going to put our b value, which is 7. My goal is to think about two numbers that will multiply to get to 6, but add to get to 7. Just like what we saw here in our example, two numbers that will multiply to our constant term, but add to our middle term. In order to do this, think about two numbers that multiply to 6 first, because any two numbers could add to 7, but there's only certain numbers that multiply to 6. For example, I could try 2 times 3. 2 times 3 is 6, but 2 plus 3 is not 7. So I have to think about two different numbers. How about 6 and 1? 6 times 1 is 6, and 6 plus 1 is 7. So 6 and 1 work. The next step of your magic X is we are going to make fractions, and you're going to put your a value on top. So my a value is 1, so I'm putting 1 on top of both of my numbers that I figured out. From here, this helps us structure our binomials. Whatever number is on top is what goes next to the x. So I'm going to have 1x and 1x for each binomial. And the number on the bottom tells me what I'm adding or subtracting afterwards. So for my first fraction, I have 1x plus 6. And for my second fraction, I have 1x plus 1. These are my factors of this trinomial. If I were to multiply these factors together, I should get back to my original trinomial. So let's check our answer. 1x times 1x is x squared. 1x times 6 is 6x. 1x times 1 is just x. And 1 times 6 is 6. I'm going to combine my like terms, and I get x squared plus 7x plus 6, which was my original trinomial. So here is the template for your magic x. We are going to multiply a times c on top, and we're going to put b on the bottom. You're trying to think about two numbers that will multiply to the top number, but add to the bottom number. And once you get your two values, you are going to put your a on top to make fractions. So let's try this again. Here I'm going to label my a, b, and c. A is 2, b is 7, and c is 6. So on the top of my magic x, I'm going to do 2 times 6, which is 12. And on the bottom, I have 7. I'm thinking about two values that multiply to 12, but add to 7. I know that 6 and 2 multiply to 12, but 6 plus 2 is not 7. I know that 12 and 1 multiply to 12, but 12 plus 1 is not 7. How about 3 and 4? 3 times 4 is 12, and 3 plus 4 equals 7. So 3 and 4 are my values. The next step is to put my a value on top. So this time my a value is 2. Now I didn't mention this in the last example because we didn't have any fractions that simplified, but if you see a fraction that can be simplified, go ahead and simplify your fraction. 2 divided by 4, both those values can be divided by 2, which gives me 1/2. Then to make your binomials, the number on top tells you what goes next to your x, and the number on the bottom is what you are adding or subtracting afterwards. So for my first fraction, I have 2x plus 3, and for my second fraction, I have 1x plus 2. Let's try this a couple more times. Starting off with labeling my a, b, and c values. So here a is equal to 1, b is equal to 6, and c is equal to negative 27. Make sure if you see a subtraction sign that you make your value negative. On the top of my magic x is going to go negative 27, and on the bottom is 6. Now, when you're thinking about two numbers that multiply to a negative, think about how many of your numbers you want negative. If you multiply a positive times a positive, you get a positive number. If you multiply a positive by a negative, you get a negative number. And if you multiply two negatives together, you get a positive. So if I want to multiply to a negative, then only one of my numbers should be negative. And I think my value should be 9 and negative 3. Notice how I chose to make the 3 negative, because negative 3 plus 9 will give me a positive 6. I'm then going to put my a value on top, and this tells me what goes next to my x. None of my fractions simplify, and so my binomials will be 1x minus 3 and 1x plus 9. You also can choose not to write the 1 in front of the x because it is imaginary. And so your factors will be x minus 3 and x plus 9. In B, labeling our a, b, and c values, my a is 3, my b is 5, and my c is 2. Multiplying a times c for the top, I get 6, and b on the bottom is 5. Since my number on top is positive, that means that both of my numbers should be positive as well. And I think I'm going to go with 3 and 2. because 3 times 2 is 6, and 3 plus 2 is 5. Then I'm going to put my a value on top and look to see if I can simplify any of my fractions. 3 over 3 can be simplified because they can both be divided by 3, and this gives me 1 over 1. And so my binomials will be 1x plus 1 and 3x plus 2. In C, labeling my a, b, and c values. A is 1, b is negative 6, and c is 8. 1 times 8 is 8, and negative 6 goes on the bottom. Notice how I want to multiply to a positive number, but add to a negative number. The only way to do that is to make both of my numbers negative, because when you multiply two negatives together, they'll cancel out to a positive, but when you add two negatives, your value will still be negative. So I'm going to go with negative 4 and negative 2, because that will multiply to positive 8 and add to negative 6. I'm going to put my a value on top. None of those fractions simplify, so I'm ready to make my binomials. I'll have 1x minus 4 and 1x minus 2. Or, without the 1's in front, you can just write that as x minus 4 and x minus 2. For my last one, I want you all to get in the habit of, before you do your magic x, look if you can factor out a GCF. Is there a value that you can divide all three of your terms by? And I think I can divide all three of these terms by 2. This will turn into 6x squared, negative 11x, minus 2. And don't forget to write your GCF on the outside. When you factor out a GCF, your numbers become smaller and easier to work with. Now my a value is 6, my b value is negative 11, and my c value is negative 2. 6 times negative 2 is negative 12, and negative 11 goes on the bottom. If I want to multiply to a negative, then only one of my values is going to be negative. I think I'm going to go with negative 12 and positive 1, since that will multiply to negative 12 and add to negative 11. I then put my a value on top and simplify my fractions if possible. Both 6 and negative 12 can be divided by 6. This will get me 1 over negative 2. So my binomials are 1x minus 2 and 6x plus 1. If you factor out a GCF, since it's on the outside, don't forget that it still should be on the outside even after your magic x. And that is how we factor trinomials with the magic x. For reference, once again, here is your template. We put a times c on top, b on the bottom. You're thinking about two numbers that multiply to the top, but add to the bottom. And then once you get those values, you put your a value on top, simplify your fractions if needed, and then turn your fractions into your binomials. Please let me know if you have any questions, and I will see you in class.